In this video, we're going to be looking at the second rule of indices. In the first one, we discovered that 8 to the power of m times 8 to the power of n is 8 to the power of m plus n. We just add the two powers together. In this next video, what we're looking at is what happens when we divide one by the other. Now, this can be expressed either with a dividing symbol or as a fraction. Doesn't matter which way you want to look at it. However, we're going to do the same thing as we did before. So if I've got 8 to the power of 4 divided by a squared, I can express it as a fraction. And if I expand it out, a times a times a times a on the top, a times a on the bottom. And because these are all bound by times signs on both the top and on the bottom, and there's a dividing symbol between them, I can cancel common factors out. So you can see I've cancelled two a's from the top with the two a's on the bottom. Remember, a divided by a is 1, so we're just replacing these with 1s. So what we've got left then is 1 times a squared. 1 times 1 is 1, and a number divided by 1 is itself. So a squared divided by 1 is a squared. Now looking at that, it might not be clear straight away as to what we've done. 4 and 2 there, I could have done 4 divided by 2 is 2, or I've done 4 minus 2 is 2. We need to now discover which one we're looking at. So the next example we've got here is b to the power of 7 divided by b cubed. You can see I've done the same thing again. I've put 7 b's times each other at the top, 3 b's times each other at the bottom, and I've cancelled 3 b's top and bottom, replacing them with the 1s. So you can see clearly when I gather all these together, I've got b to the power of 4 divided by 1 gives me b to the power of 4. So 7 and 3 gives us 4. 7 take away 3 gives us 4. Okay, so what we've discovered then is that if I am dividing two bases by each other, I just subtract the powers from one from the other. So I can say in both of these cases, a to the m divided by a to the n is a to the power of m minus n. It doesn't matter if it's a fraction form, we just discovered it's the exact same thing. This is rule 2. Okay? You need to know this one as well. Right, so a few examples. I've not written these up in advance, so please bear with me. The first example I want us to have a look at, just to get our teeth around to this one, we've got c to the power of 8 divided by c to the power of 2. Nice and easy. We just say we subtract the powers. C remains the same. 8 take away 2, 6. Easy peasy. Part B, or example 2 even, my apologies. D to the power of 9 divided by d to the power of 4. Well, we know it's going to be d because they're both the same base. 9 minus 4 is 5. Third example. And just as before, when we did our timesing ones, we had to have examples with numbers in front of our letters. Let's see what happens when we do 12q to the power of 9 divided by 2q to the power of 6. So the same again. We look at the coefficients first of all. Because they're not anything to do with powers, we just divide them normally. So 12 divided by 2 gives us 6. Then we can deal with the indices one by one. So q to the 9 divided by q to the 6. Well, we know it's going to be q because it's the same base. 9 minus 6 gives us 3. 6q cubed. Let's just make sure we definitely know what we're doing here. Let's say we have 20r to the power of 5 divided by 4r to the power of negative 2. Again, 20 divided by 4 gives us 5. We're happy with that. We know that the same base, so we'll just put an r next to it. Now, this is where it gets a bit trickier. 5 take away negative 2. Just a little recap then. 5 minus 2. Well, if you subtract a negative number, that's the same as adding it back on. So it's 5 plus 2, which gives us 7. Okay, just put it to one side. So this 5 take away minus 2 gives us 7. And just as before, it could still be a fraction. Let's say we've got y to the power of 7 over 2 divided by y to the power of 5 upon 2. Well, we've got the same base first of all, so that must be a y. On the fraction, both of the denominators are the same, so it remains the same. Then, because the denominators are the same, we just subtract the numerators. 7 minus 5 is 2. We know that 2 divided by 2 is 1. But as we saw in the previous example, when we looked at 5m, if it's just 5m on its own, or 5m to the power of 1, we know that this was just the same as 5m. So we don't need to be putting the power of 1 on this. We can just rewrite this as being y. And similarly, as we did before, if the bases are different from one another, refocus, there we go. If the base is different, let's say we've got x to the power of 7 divided by t to the power of 3. These bases are different from one another, so they must remain separate from one another. So we just rewrite this as a fraction, x to the power of 7 over t cubed. There's no more that we can do with that. There you have it. Please try some examples for yourself.